Good, good. Yeah. So how many of you have heard about like account abstraction? I'm sure like if you're following any of the discourse for the last 6 months, it's kind of everywhere, bit of a meme now almost. A lot of people talking about it. Of course, Vitalik was one of the first to do that about a couple of years ago when he proposed EIP 4337 as well. But yeah, anyone kind of who has used or is already using, looking to use account abstraction in their own applications, show of hands. Okay, a few people, right? Good to see. So yeah, I'll basically today take some time out to dive into what account abstraction is, but more importantly, why account abstraction is, right? How did we get here? What were the sort of steps it took the space to reach to this point where there's this new standard that everyone wants to use to be able to simplify the user experience in their own applications. So yeah, this is me. This is account abstraction, which is lying squarely in the path from metatransactions to intents. Right. So, yeah, a lot of text there. Sorry about that. Basically, you've all used MetaMask, right? You've all done on-chain transactions. So you all know that maybe for the first time when you came in to do a transaction, what sort of an experience it was for you. I remember mine very well because it was a basic swap on a DEX. So first of all, downloading MetaMask itself, downloading this non-custodial wallet, understanding the concept of a seed phrase, backing that up. I remember how much time that took me, what concerns I had, like what the fuck happens once I lose this piece of paper, right? So all those things, but even once you're in your MetaMask and let's say you send some funds using an on-ramp or a friend or a centralized exchange, and now you have some tokens, right? Now you want to do things, you want to invest in the decentralized fashion, like all your more Web3 native friends have told you to. You went to do the transaction and first you had to do an approval, you signed transaction, paid gas, and yeah, I was like, okay, the transaction is done, but apparently it was just the approval, right? So these things are a bit of a problem or a massive problem to onboard Web2 native people into the space. For them, like understanding wallet creation, understanding gas management, what gas is, how much gas a user needs to pay, what is the gas token? On different chains, the gas token is different, right? How do we get these different types of tokens to pay for that gas? And how much gas needs to be paid so that my transaction isn't stuck or makes it on chain in time, all of these things. Not super easy. Then nonce management, like this is something that most of us maybe don't even use in the day-to-day, but if you want to do, some things in Web2 you would consider very basic, like how to cancel a transaction, how to replace a transaction, how to speed up a transaction. These are like basic things from a user journey point of view, but to do them in a non-custodial MetaMask wallet, let's say, is not easy. You need to understand what nonce is, and it's not even under one of the main settings. You have to turn on advanced settings and go into experimental to access features like this. So, and yeah, with the concept of multiple chains, you also need to know like what each chain network is. You switch networks, sometimes your transactions aren't going through, and that's because your RPC provider isn't working. And what is an RPC provider? And you switch out to a different provider, and like all sorts of hell that we kind of go through to participate in this decentralized ecosystem. So there's these two categories of the biggest friction points in Web3 today. One is a super complex wallet experience, and one is a super complex transaction layer experience. And of course, there have been people working on both of these for the past many years, right? And at Bioeconomy, we are one of them. Like since 2019, we've been in the space. Our meta-transaction product has been around since a long time. We have projects like Decentraland, Sandbox, DYDX all using us currently. And the use case was simple. How do you give this gas abstracted experience to end users, right? That's what we came out with the offering. We called it like the gasless solution, gasless product. We had an SDK, APIs for projects to build with, right? The concept there is simple. in a normal transaction, you, let's say, want to do a swap, you set gas, you pay gas, and you send it to an RPC provider, and the provider puts your transaction on chain, right? Via a mempool, of course. But with the meta transaction, that is not the flow. Because here, if you are the person, entity doing these things, then you're the one who has to manage all these specifics that as an end user, you may not really need to know about, right? So in a meta transaction flow, what happens is, instead of the end user putting the transaction on chain, like specifying everything, including gas, all of that, the user just does a signature. They don't need to worry about underlying gas complexities. They just do a signature. They sign this thing called a meta transaction. It is what it sounds like. It's a transaction inside a transaction. So the signed meta transaction essentially has the actual transaction that you want to send on chain within it. This signed meta transaction comes to like the Biconomy relayers. The relayers interact with a contract called trusted forwarder. This flow is specific to a certain EIP called EIP 2771. But yeah, the meta transaction goes to the trusted forwarder, which does signature verification, which is checks to prevent replay attacks, and yeah, it then sends that transaction on chain. So from an end user standpoint, they just sign and the transaction is done, right? How much gas is to be paid, all of that is abstracted away from them. And in our product's case, it's not even the user paying the gas. It is actually the project who is sponsoring the gas for their user, right? Hence, gasless. So it's like the project holds a gas tank with us, they top it up, and whenever the relayer is the entity who's actually paying the gas on chain, right? So whenever they actually pay the gas on chain, they just keep deducting the amount from the gas tank balance. Now, relays also are used in a bunch of other places. You may have heard of Chainlink Keepers or Gelato, where these are used for automations. And again, that's another way to simplify user experiences where, as a user, I want to be able to place a limit order, right? In normal DEXs, limit orders haven't been possible. You need automation to do things like that. And there's a lot of other use cases for automation as well. So using relays, using meta transactions, we've been kind of simplifying the transaction layer experience a little bit for the past few years, right? Now, what about the wallet experience itself? For that as well, for the past few years, there have been a bunch of projects out there. I'm sure you've heard some of those names like Web3Auth, Particle Network, Arcana from India, and many others, right? Who are essentially allowing users to onboard to their Web3 wallet without a seed phrase. There is actually a seed phrase, it's just that the user is not exposed to it. So how that works, and we can dive into certain levels of details later as well if you guys want. How that works is essentially the private key is sharded and stored in a bunch of different places, hence MPC, and either like a Shamir secret sharing based mechanism or a threshold signature scheme mechanism is used to reconstruct the private key or sign the transactions, and then yeah, that transaction gets sent out. End user doesn't need to like store their private key somewhere. They just log in with Gmail and they can just use those applications, right? But the problem with both of these is that these are not like enshrined at a protocol level almost. So these are like very standalone solutions that cater to niches. For example, with gasless, there's a bunch of restrictions that come in that, you know, you as a developer, your own contract has to be compliant with meta transactions. You have to make some few lines of code changes in your contract to be able to do meta transactions at all. And then within that also, there's some more restrictions like you can't do meta transactions for native token transfers and things like that. So the natural next step for the UX layer, for the wallet layer, for the transaction layer has been account abstraction, and this has been for a while. Vitalik proposed the standard a couple of years ago as EIP 4337. Of course, that was a protocol level change, but what has gone live currently is not. It is a standard ERC 4337 standard, which essentially, you know, sets it sets a standard for how these different actors interact with each other to abstract as much complexities away from the end user as possible. But yeah, first of all, what is account abstraction? It's a very abstract sounding term, but the name is actually very apt because what it means is you are essentially abstracting away the private key from the account itself, right? In an externally owned account or an EOA, for example, your MetaMasks, your Coinbase wallets, your any other wallets that you probably use, even like these MPC wallets like Web3Auth, etc., they're also externally owned accounts. How they work is the private key and public key pair is essentially directly linked to the account. If you lose your key, your account is gone. But that is not the case with smart accounts because smart account is essentially governed by a smart contract. It's a smart contract. It's a smart contract that is being used as an account, and you can program it to be powerful, to have different features, so on and so forth, right? So essentially, account abstraction comes in, says that, okay guys, use smart contract wallets for your users instead of EOAs, and your life will become easier. You will be able to program your user accounts as a developer. So a lot of power comes into your hands as a developer as to what sort of features you want to offer, and you are able to implement it. Here, we'll dive into some of these in a bit, but these features will naturally sound more like Web2 native sort to you, right? Things like account recovery. If you have a private key that you're using for your smart account and you lose that private key, your smart account is not gone. You can recover it as long as you have written that in the code, right? There is no need also for one private key to be linked to a smart account. I'm sure a lot of you have heard about Safe, right? It's a multi-sig. A lot of people use it. Most DAOs, organizations on-chain use it to secure their treasuries, and all like co-founders, treasury managers, etc. have one private key that is linked, and only when a certain number of people sign does that transaction go through, right? So these type of custom user journeys can be built by just coding them into the smart account itself, right? So essentially, account abstraction has come in. It went live in March of this year, ERC 4337. We, as Biconomy, released our SDK in April. And yeah, we started, it's still very early in the space, but a lot of projects have started to use that. And the aim is to give this Web2-like user experience using all the learnings we've had in the last few years, right? Like, allow users to sign in simply with the social login. Allow users to, transact. Either projects can sponsor the gas, or user can pay gas and ERC20 tokens, right? Batch transactions. So no need for you to say have an approval and then a swap, right? You can just batch them together. And if you think about more complex DeFi use cases, for example, where let's say I want to swap my token from A to B, and then I want to put that into a yield generating protocol. So that's like 3-4 different steps. But with account abstraction, and if the user is using a smart account, they can just batch those into a single click and a single transaction. Simpler UX, lower gas consumed, everyone wins, essentially. So I'll dive a little bit deeper into the architecture of this ERC itself, ERC 4337, and I'll talk a little bit more about the different actors that are involved, right? So the first actor is obviously the individual user, the end user. Let's say there's a few different users who are sending transactions. In ERC 4337 context, these are called user operations or user ops or op as written in this image. So different users come in and send these operations, right? Okay, I want to do an approve and swap. I want to mint an NFT. He wants to, withdraw their stake from some contract. All these types of operations. Now, the benefit of account abstraction stems from the fact that, like earlier we talked about, right? The private key is separate from the account. So essentially, the end user is not actually the one who is sending these transactions on-chain, right? Earlier we talked about metatransactions and relayers. It was relayers who were doing the transactions and paying for the gas. Similarly, in account abstraction, it's just the next natural evolution of metatransactions. So in this AA world, we have an entity called a bundler, written here as an executor with the EOA, or these bundlers pick up these multiple user operations from a lot of different users, right? And then they send it to this contract called the entry point contract. Now, there's a few different methods within that Vanshika will also dive into deeper later in her talk. But briefly, handle ops is like the first method that is used to call the entry point contract. The bundler sends a bundle of user operations, and again, it doesn't need to separately send each transaction. Batching is again happening here at a bundler level. It picks up multiple user ops, makes a bundle, and sends it on chain towards the entry point contract, right? So again, gas savings involved. It sends it to the entry point contract. It calls validate op. So entry point contract is like this one source of truth, right? It does validations. It executes the actual transactions happening. There is only one entry point contract on each chain. It's essentially a singleton contract. All different account abstraction wallets, bundlers, paymasters, all talk to the same entry point contract to get those transactions done. So our bundler friend here has sent this transaction, send this bundle to the entry point contract. The entry point contract is separately like validating with each smart account that okay, he wants to swap this token, but does he even have the original token to begin with? Or okay, she wants to claim her rewards, but did she stake? Is this signature correct, right? Things like that. It just validates the operation and then it executes the operation, right? And takes, bundler is the one entity here who is paying for the gas to do all of this. So within that operation itself, the bundler also takes the gas refund from the smart account, right? How many of you are like completely not following me here, think I'm speaking out of my ass or something else? Okay, great. So the stepwise here. Bundler picks up the user operation, sends them to the entry point validates everything, does the transaction. Bundler is the one paying for the gas, and the entry point is like, okay, bro, you front the gas, I will get the gas refund from the smart accounts back to the bundler, right? So all of this happens in the single flow, and that is essentially the ERC-4337 architecture. There is another element to it that we didn't cover in the previous diagram, and that's a paymaster. Now, we've talked about user not paying for their own gas, right? Or even user paying for their own gas and other tokens. How that is accomplished is through a paymaster. A paymaster is essentially an on-chain contract, and there may be some backend services involved as well. But it's a contract that holds gas tokens to pay for users' gas, right? Let's say we're doing all of this on Ethereum, so paymaster is holding a bunch of ETH, and based on dApps, obviously someone is paying for this gas, right? So there's two types of paymasters. One is sponsorship paymaster, where dApps come in and they're like, okay, I want to incentivize my users to do transactions, so I will just sponsor all of their transactions, right? Or I will sponsor some of their transactions based on conditions. Maybe only BAYC holders get gasless experience, others pay for their own gas, because why not? So in the paymaster flow, there is this in a sponsorship paymaster flow, there is this entity who is fronting the gas, and whenever the transaction is happening, the bundler will take the refund from the paymaster instead of taking refund from the smart account, right? Because the bundler is the entity who's paying gas. The user is like abstracted away. User is like, okay, this is my transaction, guys, keep sending it. But bundler is sending it, and then when the transaction is done, the bundler gets the refund. It may be from the user, it may be from the paymaster. Now, in this paymaster as well, there can be another added step where instead of the dApp or the project sponsoring their users' gas, they can say, okay, why not allow users to pay gas in ERC-20 tokens? Because anyway, the user is not paying gas directly, right? It's the bundler who pays gas. So let's allow the bundler to front the gas, and let's give the bundler a refund from the paymaster. But then also let's allow the paymaster to take a refund from the end user in any ERC-20 token, right? And this is obviously a dependency heavily on the paymaster. So if I am building a paymaster, I can say that, okay, I am happy to accept gas fees in, let's say, only stable coins, because that's the only crypto I think will hold its value or something. Or I don't want to take on too much price risk, whatever. That's completely up to the paymaster. But the paymaster can essentially just pass on the bill back to the user, but allow them to pay in other tokens, right? So we're seeing now how this sort of different gas abstraction experiences are enabled using account abstraction, where the user may or may not need to pay for gas, but in general, their life is easier. They don't need to worry about gas as much. right? They can just pay it in other tokens. They don't need to worry about how much the price is on-chain, are fees spiking. That's being handled by entities like bundlers. The token side is being handled by entities like Paymaster and so on. Yeah, so that is at a high level, I guess, or not as much high level, the ERC 4337 flow. I will allow you guys to ask me any questions immediately on the flow right now before we move on to the full stack for ERC 4337, and we'll dive in a bit deeper into those topics. Any questions on? Yeah, go ahead.
Yeah, so Biconomy is providing their own architecture, right?
Correct. So at Bioeconomy, we have built out the entire account abstraction stack. So perfect. Brings me exactly to this slide. This is what we built out. We have Bundler as a service. We have Paymasters as a service, right? And by Paymasters, again, here we mean both types of sponsorship Paymasters, where you as a project come deposit gas tokens and your users' fees are sponsored, and even token Paymaster, where we are managing on behalf of the end users that, okay, you pay gas in stables, you pay gas in wrapped ETH, wrapped Bitcoin, whatever, we will handle the swaps for you, and we will kind of front the gas tokens for you, right?
Okay, so talking about the architecture of Bundler covers the gas fees,
Yeah.
right? Or for the simulation part.
No, even on-chain, when the transaction is sent, the bundler is the one who pays the gas.
Okay, then when it sends to the entry point contract and it gets executed, it compensates or reimburses to the bundler.
Yeah, so there's a few different components in the user of flow. It starts with the handle ops when the entry point contract is called. Then there is a validate op or a validate paymaster op if it's going via the paymaster. And then there is execute op, right, where the actual transaction is being executed. Then there is also post op, where all these refunds happen.
Yeah, so I'm talking about reimbursement part. Like bundler is getting reimbursed by the entry point after that post execution.
Correct, yeah.
Okay. So what's in it for bundler? Like it's just getting compensated? Like
yeah,
so, incentivization model?
Correct. So we are coming to the natural next steps as to why should anyone run a bundler? Why would Bioeconomy do any of this? The point is, so for a bundler, there can be a couple of different types of business models. One is thinking of it as a SaaS product, because at the end of the day, what a bundler is an RPC endpoint. It's a very specific advanced type of RPC endpoint. But if you're using bundlers as a dApp, if I'm using bundlers to send transactions on-chain, then I don't need to use a normal RPC endpoint like Alchemy, Infura, or something else to send transactions on-chain. So bundler service providers can have a SaaS model like that to compensate themselves for their work. Or bundlers can also actually make money on-chain. See in this flow, there are multiple user ops here, and then the bundler bundles them into a single group and sends them onward, right? When the bundler does this bundling, it actually reduces the gas being consumed by that batch. So there is this arbitrage essentially that bundlers can make, and that can be a part of bundler profits.
So right now, is there any incentivization model for bundler by Bioeconomy?
So for us right now, we have a very simple gas premium-based incentivization model where whatever gas the bundler pays on chain, it'll just deduct, it'll compensate itself with a 5% gas premium, taking a slightly higher gas fee from the user.
Why is there need of, why does Paymaster have to be there codependent with the bundler? Like, can't it be completely separate in normal ERC-20 token transfer as well?
So Paymaster is refunding the bundler, right? A smart contract wallet cannot originate transactions in the sense that it uses a bundler to send those transactions ahead. If you are asking why does a Paymaster need a bundler, think back to the...
I'm asking, why can't there be smart contract wallet with a Paymaster? Why can't those two combine instead of having it within ERC-20?
So that will just be a different way of doing things without ERC-437. It will be a different standard or not a standard, however you want to put it. But you can build flows where a bundler as such is not there, but you will still need some entities to relay those transactions. Because otherwise, see, the bundler is essentially an executor with a EOA. The smart account is not an EOA. So, on-chain, on Ethereum today, or these other EVM chains, you need an EOA to initiate a transaction. And that job is the bundlers. Does that make sense?
But a smart contract can initiate the transaction.
Smart contract cannot send transactions on-chain. Yeah?
I think he's asking, can the users directly call the entry point instead of going through the bundler?
Can users directly call the entry point?
Instead of going through the bundler.
That's a good question. Can users directly call the entry point?
They can, but then it doesn't make sense. It's EOA again.
Yeah, I mean, there is an EOA that needs to be involved, right? So whether you call it a bundler, you call it a relayer, someone has to be there.
Just signature, to do the signature, signing process.
Yeah, to do the signature and pay for the gas. Because that is the entity that is actually sending the transaction. It's not technically the smart contract wallet.
How is the token upload process covered in the ERC policy?
You mean which token approval?
In typical right now, we just need to do the transaction.
So in that, what happens is token approval is still there. It's just batched together. So in a single transaction, you have approve and swap. So those two go together atomically. So if one reverts, both revert. That sort of flow, and that's it. Like it's there. It's there. It's just not. User doesn't need to sign for it separately. It can sign for the entire batch together. Okay, cool. So I think.
So yeah, recently I was like diving into Paymaster to get across all these streams, and I was working on ZK-Sync Era. They recently, I think, launched their custom Paymasters. They recently launched their Paymasters, right? So I was looking into it and I saw like, so if a user can, they have a tutorial actually about it. So
Okay.
a user can pay in like any ERC20 token as if like they have the custom Paymaster for that, but they're right now only on Deadfest. So what I did was I integrated an Oracle with it. So let's say if a user wants to pay in, let's say USDC instead of gas fee. So if they have USDC in the wallet and they just want to use that as a transaction. So the smart contract can fetch the price from the Oracle.
Yeah, so that's how token paymasters work. So even our token paymaster relies on a Chainlink price feed because it needs to know how much USDC to take, right? Otherwise, yeah.
ZK-Sync Paymaster is using AGS fees, AGS. So yeah, that's
What?
You're using Chainlink, right?
Yeah. Yeah, ZK Sync also is a bit different from other ZK EVMs. It's a type 4 ZK EVM, right? So all of this doesn't translate to ZK Sync Era. There can be no concept of a bundler because there is native smart accounts. So your question, why do we need a bundler? On ZK Sync, you don't need a bundler.
They have a Paymaster flow that is
Yeah, you still need a paymaster, but you don't need a bundler on ZK Sync. Cool. So I'll quickly cover like what is the stack that we have built out, right? So at its core, it can be thought of as 4 different parts. One is the smart contract wallet itself, right? The next is the bundler, the next is the paymaster, and then is the SDK via which you as a developer can kind of use all of these things. The smart contract wallet is obviously one of the most important parts of this entire ERC 4337 flow. And when building that out, there's a few considerations to keep in mind. One of them is essentially that, smart accounts can be very use case specific. So me as a dApp, I might want a certain type of recovery module. If someone else is building something that is more like a DeFi bank, then they might want something like a nominee system where if the user doesn't use their wallet for a year, the ownership is passed to someone else, right? Someone else might want, a signature-less system where I use something like a session key to essentially not have any more pop-ups. So these are custom features that different dApps might want, different wallets might want. So for us, we've built out a modular smart contract wallet. What that means is that you can come in, build a module on top of what we have already, of the base account that we have, and then you can easily plug in this module to work directly with our smart accounts. There is no need to build a smart account yourself from scratch. So all the features we have, things like batching and session key modules that we have built out, passkey implementations we've built out, etc. you can use. You also don't need to fork the contract and do something else. You can continue using the same factory. All you need to do is plug in new modules. right? Now, when we talk about modules, there can be a lot of different types of them, but there's one particular type that I want to touch on, and that is actually a validation module, right? So think of how transactions happen on blockchains, on EVM blockchains, right? There is an ECDSA signature that is used. So basically, a private key needs to sign the transaction, right? Now, what if I tell you that there is now no need for a particular, let's say, private key to come and sign a transaction? So essentially, instead of looking directly for an ECDSA signature to validate and send any transactions from smart account, we can have custom validation modules. So we can accept different types of signatures. We can accept passkey signatures. So passkeys are essentially, in your phone you have your secure enclave and it follows a different elliptic curve, but you can just sign with your fingerprint or Face ID. It's becoming fairly popular in Web 2 these days. But even in Web 3, you can allow passkeys, which again do not follow the ECDSA signature, but you can use that for doing this validation. And again, you can think of more and more different custom ways. Recently, I was talking to a protocol who are essentially putting on a ZK proof into the validation layer. They're just authenticating in a decentralized fashion if someone has a particular email ID or something else. So they're doing like a social login, and then once they have validated that, they are creating a ZK proof for that and putting it on chain, and the ZK validation module is validating that okay, this person is really who they say they are, right? So the requirement for an EOA for a private key, that itself is disappearing now. You can have fingerprint native smart account, you can have social media native smart accounts, and yeah, it's a very different world away from the complexity of seed phrases. Right. So we've been talking about account abstraction a bit, and we've talked about account abstraction a lot over the last, let's say, almost a year, 6, 8 months, 9 months. But in the last like 3-4 months or so, there's also been this thing called intents, right? That people have been talking about, and it's a easier to understand word compared to account abstraction, but it's a much tougher to understand concept compared to account abstraction. So does anyone want to take a stab at telling me what they think intents are? I'm surprised that Aditya is not raising his hand. But okay.
Yeah.
Go for it.
So it sounds very simple, intent based. So
Yeah.
whatever your intention is regarding a transaction, you just say that intent, and everything else is abstracted. So if I want to just swap something, and I don't care what the path is, I don't care what bridge to use, I just tell it, it will do it on the rest of it, making like the UX now.
Correct, right? So instead of specifying things, you tell your goal and it's done. Or someone else will do it for you. That's the high level concept. So another way of thinking about this entire journey from me using my MetaMask and setting everything down to the T to starting to use smart accounts and metatransactions and saying that okay, you guys manage gas, I don't care about that, to now this concept of intents. You can think of it as like the EOA sort of world was like CLI, where only the geeks, nerds were sitting on their computers and able to use it. And then with account abstraction, it's more of a graphical user interface. People are able to visualize things easier, use things simpler. And then with intents, it's just purely natural language based, right? That you give a concept, a goal to the intents engine, and it executes that for you. So yeah, I don't think there is any good intents definition as such, because it's a bit abstract, but I think this covers it, right? Like you essentially are having a goal, and if that goal is fulfilled, then your intent is fulfilled, right? It's separate from a transaction where you specify particular actions to be done. So I've listed a couple of different examples here, and you'll be able to visualize the differences better, right? So an example of a transaction or a batch of transactions is that, okay, sell my Bored Ape for at least 100 ETH and buy another Bored Ape at floor price. So what will I do? I will come in, I will list on OpenSea 100 ETH, and then once that transaction is done, then I will just use that 100 ETH to buy whatever is the floor Bored Ape available, right? Now, if you look at it from an intents lens, then it looks like sell my Bored Ape and buy another Bored Ape while making as much ETH in profit as possible. There's a small nuance between these two. So in the second intents example, I'm not actually saying if I have to buy both at a higher price or both at a lower price. I'm just saying that overall I want a higher profit. So it's up to the intents engine of when to sell the ape, because maybe when my ape is selling for 100 ETH, then the floor itself is 95 ETH. But if maybe 3 days ago I had sold it for 60 ETH, then I would have found something at a 30 ETH floor, right? So intents just passes on a lot of decision making as well towards others. We call them like on-chain solvers or off-chain solvers. But yeah, that's the concept that you are not putting in the effort of calculating the nitty-gritty details of transactions. You're just giving your goal, and someone else is fulfilling that for you. Couple things I wanted to highlight is that intents are a spectrum. We see intents currently as well, even in our day-to-day. So when you use a DEX aggregator, that is kind of like a low-level intent. You're just saying that I don't care which liquidity pool you're doing the swap on. Just give me the best price. And maybe the DEX aggregator will use 3-4 different smart contracts to 3-4 different AMMs to pick up liquidity from and do those swaps, right? And then there can be something very abstract as, let's say, me just saying, hey Siri, swap all my USDC into equal parts of wrapped Bitcoin and ETH. And there is a lot of steps happening before all these things are translated into transactions and executed on-chain for you, right? Another thing I wanted to mention is account abstraction is essentially a standard that allows the execution of certain common intents. Now, what types of intents are these? So ERC 4337 itself, as a standard, allows you to do any intents that fulfill these three conditions. In that they're single chain, because in 4337 there is no native cross-chain messaging layer built in. So as long as your intent of doing a transaction is on a one chain, then that works. Second, it must fulfill is that the intent needs to be the user related to the user account. So if I'm saying something around, let's say I want to be able to recover my account or give my account to someone else if I die, or send funds to XYZ when a certain condition on my account itself is fulfilled, then you can use 4337 to do it. But if there is some intent that is based on on-chain conditions, let's say based on how the price conditions on a certain liquidity pool looks like, or anything to do with liquidity, mostly anything to do with value that is outside of your account, then account abstraction itself will not be able to solve that intent for you. There will be other types of solvers needed. So basically, intents require three types of solvers to be able to do these things, right? The first one is going to be AI, so that I am able to just give my commands in natural language, and that is passed and translated into blockchain. What the transaction looks like, what the call data is going to be, how much swaps need to be made, this, that, right? So that is the first part of the stack where people will be using like LLMs or other advanced AI tools to convert your natural language into transactions. The next part is account abstraction, right? So you can think of a few different types of intents that are actually fulfilled by the 4337 standard. For example, pay for my account's gas in USDC. That is an intent, right? I'm not specifying how much USDC you're going to use to pay for gas or which particular transaction you can pay for or anything like that. I'm just saying that I'm happy to pay for all my gas in USDC. So that is an example of a user intent within the AA world. Then, for example, session keys is another good example. Session keys are essentially a new private key you can think of that has permissioned access into your smart account, right? So normally in any account, what happens, your private key owns the account, right? So if I want to send 100 ETH or 100 USDC, whatever, from your smart account, then you need to sign from the private key. But in case you have a session key enabled on your smart account, and again, this also happens via the validation modules I was talking about earlier, where there is no dependency on everything having to be signed by your private key. You can have other forms of validation, and session key is a very good example of a different form of validation. So you can have a session key that, you say, I'm playing a game, I create a session key and give this private key to the game company, to the game developer, and they store it. And this private key only has access for the in-game NFTs. So using that key, the game developer will be able to, mint, burn, send, whatever they want to do with the NFTs that are associated with their game, but they won't be able to touch anything else. And you can think of similar session keys for a lot of different things. Maybe for a DeFi protocol, this looks like, allow the DeFi protocol to spend 1000 USDC per day from your smart account, right? Another example of a session key. And why it's called a session key is because it's valid for a certain time duration. So I can create, let's say I play a game for 3 hours every day, so my session key can be 3 hours long, and whenever my gaming session ends, the session key also expires, and you can't do anything with that session key anymore, right? So that is another great example of how intents are put into action via the ERC-4337 flow, right? And yeah, within that also, I talked about spending limits a bit. Similarly, spending limits are also an example of intents in smart accounts. So, you just say that, okay, $100 per day is what you can spend from my smart account, or what I can also spend from my smart account. That also you can define, right? Let's come to the last chunk of these, which are these different MEV applications or protocols or these solvers, right? Which are essentially needed to translate intents into transactions and execute them. So there's a lot of examples here. Maybe you guys have used something like CowSwap, where instead of setting gas, paying gas, doing an AMM swap, you just sign an intent that, okay, I want 1 ETH, I'm ready to pay $2,000, right? And someone else who also signs that intent, the solvers of CowSwap just match you guys, and then that transaction happens. So that is another example of an MEV solver implementing intent that's been going on for a while. But moving forward, there's more advanced types of solvers coming in and protocols for solvers coming in. And most of these are looking at things from a cross-chain lens, because for single-chain intents itself, what we already have with account abstraction, and we will potentially have very soon with AI, and we have with intent protocols like CowSwap, all these together are powerful. But for doing these things multi-chain across different non-consensual layers, you need something that is a cross-chain intent-based protocol. So protocols like Suave, Anoma are working on this. And this essentially changes how you think of MEV itself, right? Because earlier MEV is just about reordering transactions. There is a transaction coming in, you do a front run, you do a back run, you do a sandwich attack and take some money off of the user. But now, more and more in this intents world, the MEV is going to come in before it becomes a transaction itself. So when it's converting from an intent to a transaction, that's where that value will be extracted. So that's where a lot of these new age MEV protocols are essentially working on. So yeah, quick one line from me from an intent standpoint will be that the end game for all of this is essentially a multi-chain MEV protocol that is built using and on top of account abstraction, and uses AI from an end user interaction standpoint to translate things like, hey Siri, take my 100 USDC and set up DCAs across 5 chains for all their native tokens. And you just sign once, maybe with just your fingerprint, and this transaction is set up, and your dollar cost averaging setup is also complete. It will keep happening for whatever number of months you specify, right? So yeah, that was me. This is our QR code. You can feel free to join our developer community on Discord. Vanshika will take over next, and she will actually dive more into the implementation of account abstraction itself, into the code of it, into some of the modules, some of the paymaster flows, how those user operations actually happen. And yeah, thank you for listening. If you have any questions, would love to take them on now as well. Go ahead.
So my question is that right now most people are using Chrome extensions in order to interact with wallets because the composability offers across different systems. Do you see that changing, and if so how do we bridge like mobile, PC and everything?
Yeah, I don't think anyone's gonna sit here and bet against MetaMask. And MetaMask is sitting with a Chrome extension, which is today the way to use Web3. So the way I'm seeing it, even in action, a lot of people are building mobile wallets because if you look at how people use Web2 today, most of it is on mobile, right? So similarly for Web3, whenever it scales, a lot of that is also going to be on mobile. And in mobile, MetaMask mobile hasn't really taken off to that level. And that's why that's become a very competitive space. So what I'm seeing right now is people are going to focus on mobile wallets a lot in the coming year or 2 years, whatever. And MetaMask itself will also be adopting this tech. I mean, they are working on account abstraction. They are working on implementing these UX simplification plays within MetaMask wallet browser extension as well. So all that will plug in there too. Go ahead.
Considering the users and talking about interoperability, what's your take on EIP 6900 and 7370?
So 6900, we are actually working on that with Alchemy. That is the modular account standard EIP for those who don't know. Essentially, yeah, our latest account implementation is not obviously fully 6900 compliant because 6900 itself is not complete as a spec. But we are working with them on finishing the spec itself. Yeah, so essentially modular accounts are very important because you as a developer should be able to plug in whatever features you need, right? If you're asking me about like the trade-offs between, let's say, a diamond standard sort of architecture like Rhinestone are following versus 6900 itself, then that is above my pay grade. But yeah, was that your question? Does that answer your question? Okay, the other EIP, which one was it? Is this the EOA to smart contract migration EIP? Yeah, so this is actually what I talked with Vitalik. Yeah, you can remove this. Talked with Vitalik about as well. He was in Bangalore a few weeks ago, 1 or 2 weeks ago. So he was very bullish on this EIP. He thinks it will go live on L2s within the next 1 year or so. And like, I have not read the full EIP yet, but from some summaries I have read, it seems like a very good way to remove the friction from migrating to smart accounts. Because right now, the biggest challenge us or others like us in the space are facing is that everyone who's Web3 native is sitting on EOS. So giving smart accounts to users means you're maybe targeting more new users rather than existing users, right? So right now, only very B2C consumer-facing, Web2-facing applications are focused a lot on account abstraction. More Web3 natives are not as much focused. They're more exploring and trying to figure out what user flows work best, right? But once this EIP comes in, and hopefully it comes in soon, but it's a protocol level change. So I am not optimistic from an Ethereum standpoint, maybe on L2s, but not from an Ethereum standpoint. But yeah, once this EIP comes in, it's massive for smart account adoption.
So any alpha for intent-based transactions or modular smart accounts?
For modular smart accounts, I would say keep following the 6900 spec as it's built out. We already have released like modular smart accounts. They just came back from audit a week ago, and they will go live in our SDK within the next 1 or 2 weeks. So you can start using those modular smart accounts right now as well. And for intents, yeah, I think I would say follow someone like Suave by the Flashbots team. It's still early and the people are looking at it from a very different lenses. Intents is not easy. The solver part, the last component I showed, right, the MEV side of it, that is not easy. AI is gotten easier now with everything that's happened in this year. But even then, you need the model to be very well trained, because if I'm asking it to do a certain type of swap and it does something else, then you as a user won't be happy, right? So intents, I do think, is gonna take longer for like truly generalized intents to come in. But with account abstraction, we already have a lot of intent implementations possible today. So for me today, the way I see it is account abstraction is your intents of today. And you can use that to do a bunch of different things, of course, within those 3 restrictions that I shared. But yeah, that itself gives you a lot of playground as well.
You can take more questions.
Sure. Happy to chat more